Hi, so today we're going to prove that the area of a triangle with vertices A, B, C, D, and E, F is equal to the determinant of this matrix times 1/2. So right here we have our triangle with our vertices labeled. And so basically what we want to do is draw around this triangle a rectangle. Okay. So now what we want to do is find the area of this rectangle and then subtract out these three triangles that surround the triangle that we want. So our area equals the area of the rectangle, which would be base times height. So E minus C, which is base, times height, which is D minus B. So that's the area of a rectangle, and then we subtract out our first triangle to make it this one, whose area is 1/2 base, which is A minus C, times height, which is D minus B, minus our second triangle, whose area is 1/2 base, which is E minus C, times height, which is D minus F. And then our third one, which is 1/2 base, which is E minus A, times height, which is F minus B. And so here we have our area. Now all we need to do is simplify it. So area equals
ED using FOIL minus EB minus CD plus CB minus 1/2 times the quantity, or we can distribute this 1/2. 1/2 AD plus 1/2 AB plus 1/2 CD minus 1/2 CB. Next triangle, minus 1/2 ED plus 1/2 EF plus 1/2 CD minus 1/2 CF. Third triangle, minus 1/2 EF plus 1/2 EB minus or plus 1/2 AF minus 1/2 AB. So
kind of goes down, but we have distributed everything. So now all we need to do is simplify. So if we look to simplify ED, we find
ED minus 1/2 ED. That's it. So area equals 1/2 ED. Next EB. So looking here, oh, there we have one. So minus 1/2 EB CD, negative CD plus 1/2 CD plus another 1/2 CD equals 0. CB minus 1/2 CB is plus 1/2 CB minus 1/2 AD. Got nothing else, so minus 1/2 AD. And then we have AB, which plus 1/2 AB minus 1/2 AB, which is just 0, plus 1/2 EF minus 1/2 EF, so that one's gone too. minus 1/2 CF, and then plus 1/2 AF. So this is what we've come up with for a simplified area.
So as I kind of cleaned up our board here, we can see that from our determinant method and from our geometric method, if we look at each term, we can see that 1/2 AD, negative 1/2 AD here. 1/2 BE, negative 1/2 EB. 1/2 CF, and so on. And we see that this here is actually this times negative 1. But when we take the area, we are taking the absolute value. So these two statements say the same thing. They are equal. So this tells us that when we want to find the area of a triangle, all we have to do is plug in to this formula and take the determinant and then multiply by 1/2, and we get the area of a triangle where AB, CD, and EF are vertices.